Okay, Assalamualaikum dan salam sejahtera.
Waalaikumsalam, Madam.
Dengar tak suara saya?
Dengar.
Dengar tak suara saya?
Dengar.
Hello? Ain Azwa, dengar tak suara saya?
Dengar.
Pelik. Okay. Alright. So, hari ini kita akan discuss topik 7. Saya akan share screen saya sekejap Alright. So, topik 7, mutation. Tak, volume saya dah tinggi. Volume saya dah 20 dah. Tak tahu kenapa. Dah 32 dah. Sepatutnya okey. Cuba saya live sini. Okay. So topic 7, mutation. Mutation, this is the subtopics that we're going to discuss today. Mutation classification and types. 7.2 gene mutation. 7.3 chromosomal mutation. Okay, chromosomal mutation. Alright, so for 7.1 mutation classification and types. So minggu ni kita akan discuss lecture 7.1 and 7.2. So kita akan discuss semua ni lah. Okay, 7.1 and also 7.2. So the objective for today is to explain mutation, classify mutation, the gene point mutation, chromosomal mutation, state 2 type of mutation, spontaneous mutation, induced mutation, define mutation, state types of mutation, physical and chemical. Okay, so I'm going to explain this part first. Alright. Okay, so mutation, this is a definition of mutation, a sudden permanent change. Okay, sudden permanent change in the amount, or arrangement or structure of the DNA of an organism. Okay, sudden permanent change in the amount, arrangement or structure of the DNA of an organism, or a sudden permanent change in gene or chromosome. Okay, so ada dua definition. So you can remember is either this one or either this one. So it can be passed to the next generation. And for mutation, we have two classification. We have gene and point mutation, gene or point mutation, chromosomal mutation. Okay, chromosomal mutation ni boleh dibahagikan kepada dua lagi lah. Structural mutation or also known as chromosomal aberration and alteration of chromosome number. Okay. So mutation, okay, mutation kita ada dua. Kita ada spontaneous mutation and also induced mutation. Spontaneous mutation is mutation that occurs naturally, okay, without human intervention. Okay, due to errors during DNA replication. So masa proses DNA replication yang awak dah belajar untuk topik 6 tu, okay, mungkin masa tu patutnya masa dia tambah DNA nucleotide tu patut dia tambah A complementary to T. Tapi dia silap. Patutnya A complementary to T, dia tambah A complementary to G. So bila dia silap macam tu, itu adalah kita panggil sebagai spontaneous mutation. Okay, induced mutation is organism is artificially exposed to mutation physically or chemically. Okay, artificially exposed to mutation physically or chemically. So dia dah expose sendiri kepada mutation. Mutation adalah bahan yang menyebabkan berlakunya mutation. Okay, contribute to genetic variation or evolution at higher rate. Okay, for example, mutation kita ada dua lah. Kita ada physical agent and chemical agent. Okay, before that, what is mutation? Mutation is agent that induce changes in DNA and causes mutation. Okay, agent that induce changes in DNA and causes mutation. There are two types, physical agent and chemical agents. So the one that cause mutation kita panggil sebagai mutation. Physical agent adalah high energy radiation. Contohnya X-ray, UV ray, alpha ray, beta ray, gamma ray. So X-ray sebab itulah kalau siapa yang pernah pergi X-ray, okay, kalau dekat sebelum nak masuk bilik X-ray tu dia ada satu sign cakap kalau awak pregnant ataupun awak rasa awak pregnant, bagi tahu kepada juru X-ray. Okay, sebab apa? Sebab X-ray tu adalah mutation. So dia akan menyebabkan berlakunya mutation. Okay, chemical agent we have colchicine, ethidium bromide, proflavin, mustard gas, nitrogenous acid and formaldehyde. Ada banyak, ingat 2 atau 3 cukup. Ingat 2 je lah, colchicine, ethidium bromide. Okay, that is mutation. Agent that induce changes in DNA and causes mutation. Okay, a mutant. Mutant is organism carrying a gene that has undergone a mutation. Okay, organism carrying a gene that has undergone a mutation. It shows new phenotype as a result from mutation. Contoh-contohnya yang ni lah, Teenage Mutant Ninja Turtle. Okay, Teenage Mutant Ninja Turtle ni, dia dah dalam gene dia dah undergo mutation. So, the organism that carrying a gene that has undergone mutation, we call that as mutant. Okay, mutant. What is the other examples of a mutant that you know? Okay, letak dalam chat tu. Sebab saya tak boleh dengar suara awak, tak tahu kenapa. Letak dekat chat kenapa, apa contoh mutant yang awak tahu? Apa contoh mutant yang awak tahu? Selain Teenage Mutant Ninja Turtle. X-Men, betul? X-Men, Spider-Man, yes, X-Men, Spider-Man. Spider-Man kan bila dia dah spider tu dah bite dia, so dia undergo mutation. Bukan mutation, dia punya gene tu dah berubah. So kalau awak tengok pun cerita Spider-Man tu, awak akan nampak dia punya gene tu, DNA tu berubah macam tu. Okay, dia ada spider punya sense lah. Okay, The Flash, The Flash, saya tak tengok The Flash. Yelah kot, The Flash. Venom. Venom ni ke? Venom, betul lah, Venom yang kali hitam tu kan? Betul. Superman, dia adalah contoh mutant. Okay, itu yang fiction lah. Fiction punya mutant. Okay, alright, so kita proceed kepada gene mutation. Sudah habis dah 7.1. 7.2 adalah gene mutation. Explain gene mutation. Classify the 4 types of gene mutation. So we have base substitution, base insertion, base deletion, base inversion. Describe base substitution. For example, sickle cell anemia as missense mutation. Explain frame shift, explain base insertion as a frame shift mutation. Explain deletion as a frame shift mutation. Okay. Alright. Macam ni saya dalam lecture saya akan terangkan yang color merah ni je. Tapi saya terangkan ikutlah. Okay, saya terangkan ABC ni ke? ABC ataupun ABCD. Okay, first kita tengok dulu apa itu gene mutation. Gene mutation refer to a change occur in the sequence of nucleotide. Okay, let me highlight for you. Okay, a change occur in the sequence of nucleotide. Okay, nucleotide in a single gene of DNA. So, kita punya DNA, kita punya monomer of DNA is nucleotide. So, perubahan tu berlaku at the sequence of nucleotide. So, if the change involve one nucleotide pair then it is called as point mutation. Okay, contohnya, ni saya tunjuk contoh lah. Okay, kalau satu nucleotide je berubah, kita panggil sebagai point mutation. So as a result, so if we change the amino acid sequence, thus the protein produced will be different. The different protein may not function as normal. So because you know about central dogma, you tahu kan central dogma, DNA kepada RNA, RNA kepada protein. That is central dogma. Okay, DNA to RNA, RNA to protein. So if there is change in DNA, okay, ada perubahan dekat DNA. There is change in DNA. So what happen is the amino acid and the protein will also be changed. Okay, that is mutation. And gene mutation can be classified into 4. We have base substitution, base insertion, base deletion, base inversion. Wajib tulis perkataan base. Perkataan base wajib tulis. Allah. Okay, wajib tulis Untuk wajib tulis. Untuk gene mutation awak wajib tulis perkataan base. Tak tulis perkataan base, dia akan jadi salah. Okay. So base substitution, base insertion, base deletion, and base inversion. Okay. Base insertion and base deletion, it can cause frame shift mutation. Okay. In this 4 classification of gene mutation, base substitution ni ada dia punya genetic disease yang awak kena tahu. Okay, yang ni. Ini awak kena tahu kat sini. In base substitution, apa genetic disease dia? Base insertion, base deletion, base inversion tak ada dalam syllabus. Okay, tak ada dalam syllabus. Ada ke? Ada satu kat sini. Ada satu kat sini. Frame shift, ada satu. Thalassemia. Okay, base inversion tak ada. Alright, so kita tengok dulu apa itu base substitution. Base substitution, one or more nucleotide pair are replaced. Keyword kat sini adalah replace. Okay, ayat depan dia dengan ayat belakang dia almost sama. Macam definition gene mutation yang lain. Keyword dia tukar dekat replace. Okay, one or more nucleotide pair are replaced by another in a sequence of DNA nucleotide of a gene. Okay, one or more nucleotide pair are replaced by another in sequence of DNA nucleotide of a gene. If one nucleotide pair is replaced by another nucleotide pair, the gene will be transcribed into different mRNA. So bila kita dah gantikan, okay, it will be transcribed into different mRNA. So the altered mRNA will be translated into different polypeptide. Okay, because it has different amino acid sequence. Okay, different amino acid sequence. There are 3 types of base substitution. We have silent, missense, nonsense. Okay, 3 type of base substitution. Silent mutation, missense mutation, nonsense mutation. Okay, you have to know what is silent, missense, nonsense. Okay, before that, I'm going to show this one. Okay, this is base substitution. This is the wild type. Wild type ni maksudnya wild type DNA ni maksudnya tak ada lagi mutation. Okay, tak ada lagi mutation. So kita ada GTG, TTC, ATA, GTG, ATT. So the mRNA will be CAC, AAG, UAU, CAC, UAA. Okay, so UAU, okay, will code for amino acid tyrosine, TYR. Okay, so what happen is, if mutated, okay, if there is mutation, okay, what happen is this A is replaced with C. Okay, the A is replaced with C. So what happen is it will translate it into different codon. So it become UAG. And UAG is the stop codon. So stop codon. Stop codon tak ada membawa amino acid yang apa-apa. Okay, stop codon dia tak membawa maksud any amino acids. So awak akan dapat awak punya polypeptide chain macam tu je lah. Ada histine, ada lysine saja. Sepatutnya dapat macam ni, tapi bila berlaku mutation, dia akan menjadi macam ni. Okay, mutation tu berlaku dekat DNA. Bila DNA dah berubah, mRNA pun akan berubah. mRNA berubah, amino acid pun akan berubah, polypeptide chain pun akan berubah. That is base substitution. Replace. Okay, so what is silent mutation? Silent mutation if the change in a nucleotide pair transform one codon into another codon that is translated into the same amino acid. No effect on the phenotype, okay, because it codes for same amino acid. For example, so this is mRNA before mutation. We have UAU. Okay, UAU codes for tyrosine. Okay, kita tengok silent mutation. Silent mutation, this U here, okay, this U is replaced by C, but it is still codes for the same amino acid, which is tyrosine. Mutation berlaku, tapi codes for same amino acid. So we call that as silent mutation. Okay, so bila silent mutation, tak ada effect on phenotype. Why? Because it still codes for the same amino acids. Okay, alright. For missense mutation, if the change in nucleotide pair transform one codon into another that is translated into different amino acids, okay, different amino acid, it can cause major change in protein. For example, sickle cell anemia. Yang inilah saya beritahu tadi. Kat sini awak kena tahu pasal sickle cell anemia. Okay, sickle cell anemia. So missense mutation, it will cause sickle cell anemia. Right? For example, this is missense mutation. Tengok dulu lah. Missense mutation. Okay, dia akan codes for different amino acid. So what happen is, this A is replaced with G. A kat situ is replaced with G. So it's supposed to be tyrosine, but it codes for cysteine. Okay, it codes for cysteine. So what happen is, it will codes for different amino acid. Different amino acid akan bagi maksud different polypeptide. So that is missense mutation. So for example, sickle cell anemia. So what happen is, sickle cell anemia, on the DNA, okay, on DNA, saya explain dululah. On DNA, base T in codon 3' CTC is replaced with base A. So it's supposed to be 3' CTC 5'. It will become 3' CAC 5'. So it's supposed to be T, but it is replaced with A. So what happened is, the codon GAG in mRNA is replaced with GUG. So this codon GAG, it will code for glutamic acid. But once it replaced with GUG, it will code for valine. Okay, valine. So soalan ni pernah keluar past year question 3 markah. 3 markah. 3 ke 4 markah, tak lupa dah. Okay, 3 markah. Soalan pernah keluar past year. Past year. Tahun bila tak ingat. Okay, so for example, this is wild type beta globin. This is sickle cell beta globin. So what happened is, the T here, okay, the T CTC, the base T thymine is replaced with A, adenine. So it becomes CAC. So what happened when it transcribe, it will transcribe into GUG. Supposedly for transcription, it will supposed to transcribe into GAG. So what happened? It will transcribe into GUG. And GAG will code for glutamic acid, but once it's replaced with GUG, it will code for valine. Okay, so glutamic acid will replace with valine, and this valine will give the sickle shape. Okay, the valine will give sickle shape. Okay, dia akan bagi sickle shape. So bila dia sickle shape, dia akan less efficient for transporting oxygen. Inilah, not efficient in transporting oxygen. Okay. So erythrocyte becomes sickle shape, may clump together and clog the capillaries. So bila dia sickle cell macam ni, sickle shape, dia akan inefficient to transport oxygen. It will clump together and clog the capillaries. So what happen? Dia akan jadi physical weakness, okay, pain, organ damage, even stroke and paralysis. Okay, that is sickle cell anemia. Kalau ditanya how sickle cell anemia happen, this is things that you need to explain. Okay, point 1 until point 3. Alright, nonsense mutation. Nonsense mutation is change one codon. Okay, change one codon into stop codon. Okay, kita tukar codon kepada stop codon. So what happen is this one. This is nonsense mutation. Kita tengok dululah. Okay, nonsense mutation. So what happen is we have base U here. This base U is replaced with G. UAG is one of the stop codon. So the process of translation will stop here. So this is the only polypeptide chain yang awak akan dapat. So what happen is for nonsense mutation, it causes translation to be terminated prematurely. The resulting polypeptide will be shorter and leads to non-functional protein. Protein tu langsung tak boleh function. Okay, sebab dia dah terus tukar kepada stop codon. Stop codon, so dia akan hasilkan polypeptide yang shorter. Right, that is nonsense mutation. So base insertion, okay, base insertion one or mononucleotide pair are inserted. Okay, so keyword kat sini adalah inserted. Insert. Dalam base substitution tadi kita replace. Base insertion kita insert. One or more nucleotide pair are inserted into a DNA nucleotide sequence of a gene. So what happened? This is the normal type. So the base insertion, so kita ada TAC, okay, TAC, okay, kita ada CAA, CAA, GGA, GGA. So what happened here? And then we have TTT. Okay, what happened here? The C here is inserted. Kita masukkan C kat situ. Patut kita tak masukkan. Tak biar je. Tapi bila berlakunya mutation, base insertion, C, the base C is inserted. So bila dia inserted C, dia akan insertkan dia punya pair juga. Sebab itulah kita panggil nucleotide pair. Sebab dia tak masukkan sebagai seorang-seorang. Dia akan masuk dalam bentuk couple, dalam bentuk pair. So C and G. Okay, C and G. So dia insert C and then dia akan insert G. So what happen is, okay, it will produce different mRNA. So it was supposed to be AUG, AUG, and then GUU, CCU, CCU. And then we're supposed to have AAA. So but what happened is once this C is inserted, so it will produce G. Yeah, it will produce G as the, okay, dia akan produce G sebagai dia punya mRNA. So dia akan baca, instead of dia baca AAA, dia akan baca GAA. Okay, I repeat, saya padam lah macam messy. Okay, so it's supposed to, dia masukkan C kan, CGG. Okay, patut dia baca yang ni, TTT, AAA, AAA. Okay, tapi bila dia insertkan C ni, okay, dia masukkan nucleotide base, dia masukkan DNA nucleotide C. So bila dia akan baca sebagai TACCAA, CTP, GEA and then GAE. Sini. Dia akan baca je ni. So dia akan baca lain lah. Dia akan baca frame yang lain. Okay, dia akan baca frame yang lain. Alright, that is base insertion. Base deletion, one or more pair of nucleotides are removed or deleted. So the keyword here is this one. Okay, one or more of nucleotide pair are removed or deleted from a DNA nucleotide sequence of a gene. So what happened? We have TAC. Okay, TAC. But we delete C. Sini ni kita delete C. Sekejap C kita delete C ni. So bila kita delete C, pair dia pun kita akan delete. So sepatutnya kita ada GUU, but once it is deleted, it will read as UUC. Okay, UUC. Macam tu. That is frame shift. Alright? So remove or deleted. So what happened is, the insertion of one nucleotide base pair has altered the reading frame. Okay, has altered the reading frame of the codons on the mRNA. So what happened? Kita dah baca lain. Okay, kita dah baca lain. Okay, mula-mula ni kita baca betul. Methionine. Tapi bila kita dah delete, dia akan jadi kita baca lain. Kita akan baca jadi sepatutnya GUU, kita akan baca sebagai UUC. Okay, dia akan alter the reading frame. So from the point of mutation, the altered codons will be translated into different sequence of amino acids. Maksudnya, start daripada point of mutation, contohnya sinilah, start daripada point of mutation, codon akan jadi lain, amino acid akan jadi lain. Okay, itu maksud dia. Kalau kita tengok methionine stay sama, Okay, start daripada berlakunya kat mana point mutation tu. Okay, contohnya kat sini lah mutation tu berlaku. So start pada situ, start daripada codon situ, dia akan baca lain. Amino acid pun akan baca lain. Okay, this mutation is called frame shift. Okay, Example of disorder due to the base deletion is thalassemia. Okay, thalassemia. So the thalassemia ni adalah deletion of nucleotide for genes which control the production of hemoglobin A and beta chain. Thalassemia major cause serious anemia. Thalassemia minor is inherited from hemolytic anemia. Okay, sebab itulah kalau sekarang ni kalau awak nak kahwin, jangan kahwin lagi lah, janganlah kahwin. Bukan maksudnya jangan kahwin, janganlah kahwin lepas matrik. Okay, nanti kalau awak nak kahwin, bukan awak kena buat HIV test saja, tapi kalau boleh buatlah thalassemia juga. Okay, buatlah. Okay, kalau ingatlah, saya dulu tak ingat, so saya buat HIV test saja. Okay, so kalau boleh buat thalassemia sebab kita tak tahu dua-dua, maksudnya bukan kita sajalah, partner awak pun kena buat test thalassemia tu juga. Okay, kalau dua-dua carrier, dua-dua jadi, dua-dua carrier, dia akan, anak awak nanti akan jadi susah lah. Okay, dia akan jadi, bukan susah, maksudnya kesian kat anak nanti. Okay, so the blood smear from individual with thalassemia shows the blood cell with small, pale and variously shaped. These small red blood cells are able to carry less oxygen than normal red blood cell. Okay, so example yang ni, this is the red blood cell, the white blood cell, the red blood cell, platelet. So what happen when there is a person that has thalassemia, this will be his or her erythrocyte. Okay, dia akan jadi macam ni lah. Macam bentuk. So an individual with thalassemia shows the blood cell with small, pale and very shaped. Berapa kali nak ulang? Tadi dah ada kan? Okay, this small red blood cell able to carry less oxygen than normal red blood cell. Itu je cerita dia. Apa benda ni? Okay, frame shift. Okay, frame shift. So codes in original arrangement of mRNA. So this is mRNA. So we can see that glutamic acid, valine, proline, lysine, proline, and arginine. Okay, well, when there is mutation, okay, for example, we have deletion. Okay, kita delete G. Ada. So kita delete G. So once kita delete G, kita tak boleh baca codon 2 saja. So apa yang jadi, C ni akan pergi pada sebelah. Okay, sama juga. A ni akan pergi move. Okay, frame shift. Dia, C ni akan pergi sebelah and A ni akan pergi pada sebelah. Okay, sebab itulah dia akan jadi UUC, CUA, AAC, CUA, GA. Okay, so what happen is the amino acid will be, ini akan sama lah. Sebab sama je, sebab mutation tak berlaku kat sini. Mutation berlaku start pada sini. So start daripada 2 ni lah, start pada sini lah, dia punya amino acid akan jadi lain. Kita tengok, glutamate, serine, leucine, asparagine, leucine. So sini tak ada. So dia akan produce non-functional protein, non-functional amino acid. Okay, yang tu. Right? So this is example of frame shift. Saya dah explain dah. No frame shift mutation if 3 base pair are deleted or inserted. Okay, maksudnya kalau kita masukkan terus 3, katalah kita masukkan 3 sini. So kita masukkan jadi GAG. Sekejap saya tulis. Okay, kita ada GAG. UUC kita masukkan G, Allah, GG. So saya masukkan GGG. So GGG. CUA. So dia tak akan ada frame shift. Sebab apa? Dia masukkan dalam 3 base pair. Okay, dia masukkan dalam multiple of 3. So tak ada masalah dalam frame shift. Tak ada berlakunya frame shift. Mutation still ada tapi tak ada perubahan dari segi frame. Alright. Base inversion. Base inversion, 2 or more nucleotide pairs are inverted. Okay, keyword kat sini adalah inverted. Okay, inverted. Mana dia? Mana dia? Highlight. Okay, inverted. 2 or more nucleotide pairs are inverted in nucleotide square sequence of a gene. 2 pair or more nucleotide sequence are inverted. Berapa kali nak ulang? Change the codon into change in the codon, then akan berubahlah amino acid dia. Okay, usually the effect is minor. So kita tengok sini, normal code is AGA, GTC, TTC. Serine glutamic acid, lysine. But after mutation, base inversion, so dia inverse. Dia T ni pergi belakang, G ni pergi depan. So dia akan jadi TGC. So serine, threonine, lysine. So kat sini je lah yang berubah. Tempat yang base inversion tu berlaku tu je lah yang akan berubah. Okay, sebab itulah dia minor. Okay, effect adalah minor. Sebab dia melibatkan satu amino acid sahaja. Okay, alright. Ada soalan ke? Celaju dah pula tiba-tiba. Ada soalan? Soalan ke? Kalau ada soalan kat tangan. Okay. Ni minggu berapa ni? 10. Okay. So, for 7.3 chromosomal mutation, kita pergi kepada dua ni je lah dulu We define chromosomal mutation, state 2 type of chromosomal mutation. Chromosomal aberration, chromosomal number alteration. Okay, Sakinah tanya soalan. Maintain protein sintesis berlaku tapi terus sakit. Maintain protein sintesis sentiasa berlaku, tapi macam mana dia boleh terus sakit? Macam mana? Template DNA tu ya. Oh, okay, faham. Ya, dia mutation sekali je, tapi dia terus bagi efek lah. Dia terus bagi efek kepada, sebab dia melibatkan gene, the DNA. Dia DNA, so dia bagi efek directly kepada kita punya phenotype. Okay, sebab mutation tu berlaku dekat DNA. So dia akan terus dia akan bagi efek thalassemia tu lah. Harap menjawab soalan awak. Okay, sebab dia dah tukar dekat DNA. Bukannya DNA tu kan penting kan, DNA. So bila dah berubah, and dia akan pass. Dia akan pass kepada next generation. So kata kalau awal-awal tu, contoh dalam fetus. Contoh masa awak fetus lagi. Dah berlakunya mutation kepada gene. So DNA tu memang sentiasa replicate. Bila replicate, dia akan replicate benda yang sama. Sama. So sebab itulah kita kalau macam thalassemia. So sampai bila-bila lah akan terjadi thalassemia. Walaupun kita punya red blood cell akan sentiasa diganti. Tak sepi sebab kita punya DNA tu dah berubah. Right? Saya nampak Fatin tadi angkat tangan. Fatin nak tanya apa? Fatin. Sah tu lah, tak ada suara ni. Fatin ada tanya soalan ke tadi? Dia angkat tangan. Tak ada, saya proceed kepada dua objektif ni sahaja. Okay. So chromosomal mutation, define chromosomal mutation and state two type of chromosomal mutation. Okay. Banyaklah chromosomal mutation ni memang dia antara part yang favorite. Okay, saya boleh cakap itu adalah part yang favorite yang untuk ditanya dalam quiz ataupun kedai quiz ada final exam. Okay, part yang favorite sebab awak tengok dia ada sampai sini dia punya learning objective. Kalau untuk gene mutation tadi, favorite part adalah frame shift dengan sickle cell. Okay, frame shift dengan sickle cell. And dia tak banyak sangat boleh ditanya. Tapi yang dekat sini, kromosoma ni macam-macam dia boleh tanya. Okay, favorite adalah yang ni, start pada sini. Favorite ni start pada situ. Okay, kita tengok definition of chromosomal mutation dulu. Yang ni kita akan sambung juga selepas. Lepas ni kita meet Sam. Lepas mid sem kita akan cerita lagi lah. Tapi before kita nak cerita, saya nak masuk dua ni je. Kejap je. Okay. Mesti awak tak sabar kan mid sem nak cuti. Alright. Apa dia? Okay, sini. Okay, define chromosomal mutation, state of chromosomal mutation, chromosomal aberration, chromosomal number alteration. Aberration ni maksudnya structure. Kita ubah dia punya structure. Number alteration adalah kita ubah dia punya number. Contohnya Down syndrome. Down syndrome kita ada 47. Kita human ada 46 kromosom. Tapi Down syndrome ada extra. Ada 47. Okay, number tu berubah. Okay. So kita tengok dulu, this is overview of chromosomal mutation. Kita ada dua, change in chromosomal structure, aberration, change in chromosomal number. Okay, so untuk change in chromosomal aberration, kita ada 4, translocation, deletion, inversion, duplication. Ni tak ada base. Okay, terus tulis translocation, deletion, inversion, duplication. Okay, and then change in chromosomal number. Change in chromosomal number ni disebabkan non-disjunction. So it may involve individual chromosome, aneuploidy, and involve sets of chromosome. So kita ada dua lah, sama ada individual kromosom, satu kromosom saja ataupun set of kromosom, keseluruhan kromosom. Contohnya kita ada 46 tu lah yang akan berlaku non-disjunction. Okay. So untuk aneuploidy kita ada monosomy, trisomy. Euploidy, untuk involve set of chromosome kita panggil dia euploidy. We have autopolyploidy or allopolyploidy. Okay, kita tengok dulu chromosomal mutation. Definition of chromosomal mutation. Definition of chromosomal mutation, a change occur in the structure or number of chromosome. Okay, change occurs in the structure or number of chromosome. Okay, structure or number. Okay, if the change occur in the structure, kita panggil dia sebagai chromosomal aberration. There are 4 types: deletion, inversion, translocation, duplication. Okay, deletion, inversion, translocation, duplication. So deletion adalah loss. Okay, loss. Kita hilang. Okay, hilang, loss. Okay, loss. Deletion adalah loss. Keyword kat sini loss. Sekejap The loss of one segment containing one or more genes. So this is before deletion. So bila kita delete, dia akan jadi macam ni lah. Kromosom kita cakap pasal kromosom. Kalau gene mutation tadi kita cakap pasal base nucleotide, base pair. ATGC, apa dia? Ini kita cakap pasal kromosom. So ini adalah kromosom. Kita akan buang satu part. Buang satu segment of chromosome yang containing one or more genes. So after deletion dia akan jadi macam ni. Okay. Sekejap Okay, kejap. Okay, for example, deletion yang awak kena tahu, example of syndrome yang awak kena tahu adalah cry-do-cat. Okay, cry-do-cat. Cry-do-cat syndrome ataupun cry of the cat. Cry of the cat in French. Cry-do-cat ni maksudnya cry of the cat in French. Okay, cry-do-cat adalah genetic chromosomal disease that due to deletion of chromosome number 5. Okay, kat sini. The short arm here. Okay, the short arm of chromosome 5. Okay, that is cridocat. So what happened is the phenotype ranging from distinct cat-like cry to additional growth. So what happened? Nanti kalau awak ada masa lah awak pergi YouTube ke, bila awak cari dekat YouTube cridocat, memang awak akan dengar ni siapa yang ada cridocat ni dia akan menangis macam kucing. Okay, dia akan menangis macam kucing. Okay, sebab tu kita panggil cridocat syndrome. Cat like cry. Okay, cat like cry. Dia akan menangis dia macam bunyi kucing. Okay, so dia selain dari itu dia akan ada additional growth, facial hair, additional growth, facial and mental abnormalities. Okay, macam ni lah. Ini adalah contoh babies ataupun babies yang ada, not babies lah. Okay, toddler. Okay, yang ada cat-like cridocat syndrome, cat-like cry. Okay, inversion adalah a region of chromosome breaks off and rotate through 180 degrees. So dia apa yang jadi inversion dekat sini ni, dia akan break off. Lepas tu dia rotate. Okay, rotate. Lepas tu dia akan rejoin the chromosome. Contohnya yang macam ni lah. Okay, ini saya letak slide ni untuk bagi awak faham sikit lah macam apa maksudnya inversion. So what happen is dia akan break off. Okay, nampak DEF ni dia akan break off. Lepas tu dia akan invert. Okay, inverse, rotate, then dia rejoin balik dah dekat kromosom yang sama. So dia akan jadi FED contohnya. Then we have translocation. Translocation is a region of chromosome breaking off. Okay, breaking off and rejoining either the other end of the same chromosome or another non-homologous chromosome. Okay, translocation ni translocate maksudnya dia akan pergi join orang lain ataupun dia akan pergi join dengan dia juga. So what happen is it will breaking off and rejoining either the other end of the same chromosome or another non-homologous chromosome. So yang macam ni dia ada sistem butter. So dia dua-dua break off kat sini. Lepas tu dia tukar. Okay, yang pink pergi ke sini, yang green pergi ke sini. Okay, kenapa another non-homologous chromosome? Sebab awak tengok dia punya kromosom dia tak sama size, tak sama shape. Sebab tu kita panggil non-homologous chromosome. Contohnya translocation yang macam ni lah. Okay, kita ada ni, break off and then rejoin. Macam tu. And the last one is duplication. A region of chromosome becomes duplicated. So a set of genes exists. Okay, a region of chromosome becomes duplicated. So a set of genes exists. So kat sini kita ada dah gene yang kita nak. Tiba-tiba berlakunya duplication. So set of gene akan duplicated. So akan tambah lagi kat sini. Dia akan jadi tak elok lah, bukan tak elok. Yes, tak elok lah. Maksudnya kita nak macam ni je. Tapi tiba-tiba ada penambahan gene. Penambahan gene, pengurangan gene tak elok untuk kita punya DNA. Tak elok untuk kita punya kromosom. Okay, itulah. Dah decide. Dah jadi Tuhan, Allah dah jadikan macam tu lah. Okay, menjadikan macam ni lah. Tak ada tambah, tak ada kurang. Macam tu. That is duplication. Okay. Sets of gene become duplicated. Okay, a region of chromosome become duplicated, a set of gene exists. Macam tu. Patutnya ada A, B, C, D, E, F, G, H, I. So F, G, H, I ni duplicated. So additional sets of genes. Okay. Alright. So for next week, this is the example. Okay, for next week, kita akan next week cuti. Next 2 weeks. Lepas mid-sem kita akan sambung chromosomal alteration in chromosome number. Okay, awak akan belajar pasal Down syndrome, Klinefelter, Turner syndrome. And this is the example of Down syndrome's animal. Okay, this is the example of Down syndrome animal. Kita ada tiger, kita ada sloth, kita ada giraffe and kita ada koala. Okay, Down syndrome it's not occur in human saja tapi boleh berlaku dalam animal. So kita akan belajar ni lepas mid-sem. Ada soalan ke nak tanya? Kalau ada soalan kat tangan. Soalan ke? Tak ada. Okey, kalau tak ada, kita akan berhenti kat sini. Okey, berhenti kat sini sahaja. And ada berapa orang? 81 orang. Ada berapa? 2 orang kot tak ada, tak datang. 81 termasuk saya, 2. So 79 lah. Ada 4 orang tak ada. So, okay, nanti saya letak je lah sebagai ponting. Okay, kalau tak ada apa-apa sampai sini saja. Thank you guys. And have a happy holiday. Okay, selamat bercuti mid-sem.